we are picking up in 6.4. We're working with these properties of integrals, right? And I had just introduced all these properties at the top, just kind of talked through them. Most of them were properties we were already familiar with. I think maybe 5 is the new one we're not familiar with. We talked about how a constant can move out. But most of the rest of these we've kind of already talked about in some way, shape, or form. So, on problem 2, we are given 3 pieces of information. The integral from a to b of f of x dx is equal to 8. The integral from a to b of g of x is equal to negative 3. And the integral from a to b of h of x is equal to 5/2. Okay, so A asks us, what is the integral from b to a of g of x dx?
Would it be the a to c to b?
No.
Wouldn't it literally just be negative 3?
No.
Oh wait, it's opposite.
So it'd be positive 3.
Uh-huh. Are we there?
Oh.
Okay, so here, what's different? Here it's a to b, here it's
I understand.
b to a. So remember the rule is the integral from b to a is equal to the opposite of the integral from a to b of g of x dx. So by flipping the a and b, it becomes the opposite. And so when we do this, it's going to be the opposite of negative 3, which indeed becomes positive 3. I probably wrote out way more than you want to write out, but that's okay. I would encourage you to write the rule out. Okay, what about b? The integral from a to b of 2 times f of x dx.
60.
I agree. That's the final answer. What's the official property or rule I can do here? That 2, that constant of 2 that's inside the integral can be pulled out front. And so this can be officially rewritten as 2 times the integral from a to b of f of x dx. And so now you've got 2 times the integral from a to b of f of x. So that is 2 times 8, which is 16. I'm writing it out so you can see what property is happening here. But on the flip side, when you tell me 16, I think you have an idea of what you're doing too. So, C, the integral from a to b of 5 dx.
5.
No? There's a specific property you need to use.
5.
Yep. Five times b minus a, because this is property number 5 from up above. Okay. When we learn how to actually integrate, you won't need that rule anymore because it'll be an easy peasy thing to integrate it. But so when you have the integral of a constant, it's the constant times the difference of your bounds, upper bound minus lower bound. Okay. If we could do more math with that, we would, but we can't do any more math with that. So we're stopping there. Okay, D. The integral of from a to b of 5 plus g of x with respect to x.
Have to do number 6.
Officially, yeah, number 6, and that there's addition within the integral. So officially, this can be broken up into 2 separate integrals. So this can be the integral from a to b of 5 dx plus the integral from a to b of g of x dx. Okay, that's the official math that can happen. It's two terms being added. You can break that up into individual integrals. What's the integral from a to b of 5 dx? 5 times b minus a plus the integral from a to b of g of x dx. I'm just writing minus plus -3 because I already had the plus sign in there. Obviously, that is equivalent to saying minus 3. Okay. E. Same thing in that there's two terms being subtracted. We can rewrite that as two separate integrals. So the integral from a to b of f of x dx minus the integral from a to b of h of x dx. Okay. So then we're at 8 minus 5 halves.
Can you make the a 16 over 2?
You can. So 16 halves minus 5 halves is going to make it 11 halves. Also, obviously, if you end up going a decimal route, 5.5. But there's definitely something to be said for staying in the fractions and remembering how to stay in the fractions. Okay, F. The integral from a to 4 of h of x dx plus the integral from 4 to b of h of x dx.
It just equals the integral from a to b. Or b to a. A to b.
A to b. Mm-hmm. So notice it's a to 4 and 4 to b, and they are both h of x, yes? So since they are both h of x, they have that boundary that overlaps. This is rule 3 from up above, your additive interval property. I've never known that name, sorry, but okay. So this can be rewritten as the integral from a to b of h of x dx. Okay, which is five halves. We're just learning basic integral rules. These are kind of, when you see these random questions in multiple choice or something, these are kind of the fun ones that, it's just knowing the properties and how to use them. Okay. Questions there? Tate, are you sold on this one?
Yeah.
Okay. I wasn't 100% sure you were sold quite yet. Okay, top of the next page. Find the following. If the integral from 1 to 5 of 3 times f of x plus 4 with respect to x equals 34, find the integral from 1 to 5 of f of x dx.
Wait.
Can't you split it out?
I kind of think of this as a big equation because we're trying to solve for the integral from 1 to 5 of f of x. I kind of think of this as a big equation. I'm not sure if that's how you have to do it, but that's how my brain works, at least in terms of teaching it. What do you say, Aiden? No. So I'm going to start this integral right here, the big one from 1 to 5 of 3 times f of x plus 4. Let's break it apart using our rules. If we break it apart using our rules, we're going to have two integrals, yes? the integral of 3 times f of x plus the integral of 4. But on the 3 times f of x, what about that 3? It can go out front. So I'm going to write this as 3 times the integral from 1 to 5 of f of x dx plus the integral from 1 to 5 of 4 dx. And that equation still equals 34. Can we agree with that statement? Now, if you need a hint of where to go next, think about that second integral and what I can do with that second integral. Well, it's only a constant.
So it would be 4 times 1 minus 5.
Reverse it, yes. 4 times upper minus lower, 5 minus 1. Okay, so I'm going to rewrite this. It's 3 times the integral from 1 to 5 of f of x dx plus, because this is the integral of a constant, the rule says it's the constant times the upper minus lower bounds. Well, 4 times 5 minus 1 becomes 16. So now I'm going to rewrite this as 3 times the integral from 1 to 5 of f of x dx plus 16, still equaling 34. Are you starting to see it? Now I can what? Subtract 16. So now I have 3 times the integral from 1 to 5 of f of x dx equal to is it 18? Okay. And then divide by 3. And the integral from 1 to 5 of f of x with respect to x is equal to 6. What were we supposed to find? The integral from 1 to 5 of f of x dx.
So how come there's no f of x in the 4 equation? Is that just because they were adding?
Yeah, because it's basically this plus this. So it's, you know, the f of x is not connected to the 4 in that sense. Okay. Okay. Okay, I feel like this is kind of a sidebar. It's important, but yet kind of thrown in weirdly, but it is true. Where the integral from 0 to 3 of f of x dx is equal to 8, then what is the value of the integral from -3 to 3 of f of x dx? And in this first case, we're going to talk about if it is an even function. Now, in order to have this whole discussion, we have to remember, what is an even function?
It's not something to do with the graph.
I heard two different things that I could not process, so
Above the x-axis.
not necessarily.
I just said something to do with the graph.
There's a couple of different ways we could talk about even, because we also talked about the graph is going to be the easiest way here. We also talked about that if it's even, f of x has to equal f of negative x. But the easiest way to remember even is it's symmetric across the y-axis. Okay, so in order to do this, we have to know that even means it's symmetric across the y-axis. Now, symmetric across the y-axis means the left and the right are the same, yes? Okay, so
Can't you see it by like the power?
Huh?
You can see it by the power.
Well, that's my thought.
Oh, if it's an even function?
But you can't because.
To an extent, but then when you start getting multiple terms, you know, if you have an x to the fourth plus an x to the third plus an x, you know, like which way do we go with it? So easiest thing is to look at the graph. It's symmetric across the y-axis. So here's what when we talk about the integral from 0 to 3 equaling 8, I am drawing a random graph here. I drew a parabola. Parabola is even, yes? Now, when we start talking about the integral from 0 to 3, that means we're talking about the area under the graph between 0 and 3. Yes? And so what we're saying there is that integral from 0 to 3 is equal to 8. Now, thoughts on if we had to do the integral from -3 to 3 in this scenario?
Negative. Or just be.
Okay, so right here, if we go over to -3, I went a little too far. If we went over to -3, what's this area going to be? 8. So the area from -3 to +3 is 16. Because 8 plus 8 is 16. Okay, so it's the idea that, okay, we can also say the integral from -3 to 0 of f of x dx would be equal to 8. This works because it was defined to be an even function, where it's symmetric across the y-axis, so the left and the right side of the graph are the same. Okay, so, I mean, in this case, because it's even, you could think of it as being 2 times the integral from 0 to 3 of f of x dx. And so 2 times 8, which was 16. And again, why does this work? Because it's even. Okay? Ready to talk odd?
Is it symmetric across the x-axis?
That'd be too easy. In other words, no, not symmetric across the x-axis. Symmetric across the origin.
So this is if it's like shifted. Like if it wasn't like perfectly on y-axis.
No, because a parabola could never be odd. A parabola could never be, it's never going to be symmetric across the origin. So it's not a shifted thing. Symmetric across the origin is your diagonal pieces match up. I also, at the time, I talked about being a, 180-degree rotation.
So
Okay.
If you folded like these two corners together, maybe it's a square.
Yeah. I'm going to use a line here, but a good one to think about being odd is the cubic function. It's not the one I'm going to use to demonstrate, but that's a good example of odd. Okay. It's a rotation of 180 degrees, or I also talk about being a double reflection. If you take like what's in this first quadrant and you reflect it twice. So if you reflect it down across the x and then over across the y, it's going to land on top of itself. Or you could reflect it across the y and then down across the x. Okay, so that's a good example of an odd function, like the x cubed. Now, I guess I could use that. In my notes, I'm just going to use a line that goes through the origin. Now, the integral from 0 to 3 is 8 again. And remember, an integral is the area between the curve and the x-axis. So that's 8. Now, what if we talk about negative 3 to 3? Negative 3 over here, that's an equivalent size shape again, right? It's a symmetric piece, but the catch is it's below the x-axis, so when we talk area, it's going to have a negative area. And so what's going to happen? Those 8 and negative 8 are going to cancel out. Okay, so you're going to end up with negative 8 plus 8, which is 0. Okay, and again, this is because it is an odd function. Okay, do we understand the difference between the two? Okay, there are definitely times, and especially when we get into actually doing the antiderivatives of functions and stuff and plugging our bounds in, which is a thing coming, there is definitely something to be said for if you know you have two identical pieces, just making it, instead of going from negative 3 to 3, doing 2 times the integral from 0 to 3. Okay, there's definitely good there because it's always easier to work with a 0 than another number, especially a negative. So, okay, ready to go draw some pictures? See how your graphing skills are? Okay. There are times, and you will see this on the AP test, where an integral is not necessarily something that you can easily integrate. Okay, we don't know how to integrate yet, so, that's a whole nother story. But there are times where they're going to say geometry skills are going to come into play. We're basically being able to graph the shape and figure out the area just using basic formulas. Not using calculus, but just using basic formulas. So, in these examples, we're going to sketch the region defined by the definite integral, and then we're going to evaluate each integral using a geometric formula. Okay? Next week, I'll teach you how to just integrate this. But for right now, the integral from 1 to 4 of x plus 3 dx. So, x plus 3. What does x plus 3 look like? What is y equals x plus 3? A line that goes through.
The origin, right?
Nope.
And then 3. No, the y-intercept open.
Mm-hmm. Think y equals mx plus b, right? This is going to be the hardest part, not the geometry, just the basic graphing, right? Okay, so we know we're going to have a line that goes through 3 and has a what? Slope of 1. Now, the more precise you can make this drawing, the better, because we're going to have to find the area by hand here in a moment, okay? So, I know there's a point at 3, right? Where's my next point? 1, 4. Okay? I'm going to keep going. Where's my next point? 2, 5. I'm going to keep going. Next point is 3, 6. I'm going to keep going. Next point is 4, 7. How far do I have to go?
That's it. 4.
That's it. I haven't gone too far though, have I? But I did have to go all the way here because we're talking the area of this from 1 to 4. So right here, there's my line, yes? But when we start talking about the area, so the integral from 1 to 4 is the area under the curve between 1 and 4. What did I just draw?
Trapezoid.
A trapezoid. So we're going to find the area of this trapezoid. I'll give you the 1/2. Times what?
1/2. Oh, yeah.
I'm okay with the 3 because the distance between 1 and 4 is 3. What are my bases?
4 and 7.
4 and 7.
That's
Is that what you said?
yeah.
What did I hear?
4 plus 7. I haven't read that.
Okay, that's not what my ear heard. I'm not gonna say it's not what you
I'm
said.
confused. I didn't know what I thought.
Okay, well, because I thought I heard 1 plus 7, honestly, which didn't make sense. Okay, and 3/2 times 11. How about 33/2? 16.5, but 33/2 is going to be your better answer.
How did I do that?
I don't know.
I changed my 1/2 in the equation to 1/3.
Oh, okay. I got nothing there. Okay. Got it? Okay, B. This is a common one in calc. They love to throw this one in. A that we just did is one that you will easily be able to integrate soon. This one is one that we never really learned how to integrate, if I'm recalling correctly. And they like to throw it in because they like you to recognize it for what it is and find the area by hand that way, geometrically.
Can you take that? Whatever that's called.
Square root.
Yeah. Can you take that off?
You cannot, because it's 2 terms being subtracted.
You can take off both of them.
But
It's the square root of the answer.
you can't do that.
Is it like the even or odd function thing?
No.
I get it.
It's a 0. Doesn't make sense.
Danny.
Okay. It comes from, no, that's not a triangle. Okay. This comes from the equation x squared plus y squared equals 4.
Makes sense.
The equation x squared plus y squared equals 4 is the equation of a specific shape. It is the equation of a circle.
What?
With those squares.
No, it's just a circle with a radius of what?
2, 4.
2. The equation you learned at one point,
I never remember that.
I think it was in pre-calc I teach it, unless it wasn't.
Oh, I see.
I don't know. The equation that you learned here is, where do I want to put it? I don't know where I want to put it. X squared plus y squared equals r squared. That is the equation of a circle centered at 0, 0 with a radius r.
Get it.
Now, so when you see this, x squared plus y squared equals 4, realize, okay, y squared is 4 minus x squared, right? And then y is plus or minus the square root of 4 minus x squared. Now, why is there a plus or minus?
Did you take the square root?
Because I took the square root. The idea is the positive square root of 4 minus x squared is the positive half of the circle. The negative square root of 4 minus x squared is the negative half of the circle.
So we need to find the positive side.
So our specific graph is just the positive square root of 4 minus x squared. So we're just looking at the top half of the circle. Or in other words, a semicircle. Like, I'm just trying to give you, I'm going to officially graph here. But I wanted you guys to see, I needed to share that information. Does that make sense?
Yeah.
Because going forward, this is important to work to recognize. So, this is a circle, centered at 0, 0 with a radius of 2. So that means what? It goes from negative 2 to positive 2. And what does it go through on the y-axis?
2.
Not that that really matters, but it does. Okay? So because it's the positive only, the positive square root, you're doing the top half of the circle. The negative 2 to 2 says we're going from here to here. And we've done this area lately, haven't we?
1/2 pi 2 squared.
Yep. 1/2 pi r squared. I guess, I don't know, I feel like we've done that lately. So yeah, 1/2 pi r squared, which is 1/2 pi 2 squared, which is 2 pi. I'm always going to leave my answer as 2 pi unless they ask for it otherwise. Okay? We've got 4 more. Can we get 4 more done?
Congratulations, suck at division.
Okay. C. The integral from negative 2 to 4 of the absolute value of x plus 3.
I think we should skip this one.
Nope.
We're going to stay right.
Let's start with what shape is this graph?
It's just a line, right?
Absolute value of x is a v.
Like the dot is at 3.
And then the plus 3 is going to take the v up 3. This I taught you in algebra 2. That's been a couple of years, I know. Does this sound familiar though a little bit?
Yeah.
Absolute value v, the plus 3, because the 3 is outside the absolute value, is going to take it up 3. Now, keep in mind, I'm going to be finding this area, so I'm going to be kind of precise about my points, right? Okay. So my v is right there at 3. What do the sides of the v do?
They go up.
They go up how? Slope of 1, up 1 over 1. Okay. So I'm going to be at 1, 4 on the right. 2, 5 on the right. 3, 6. 4, 7. Why did I go to that point? Because we had to go to 4. And then we also have to go to negative 2. So I'm going to work on the left side of the v. Negative 1, 4. Negative 2, 5. Maybe you don't need to draw it out like that dot by dot, but I do. And we were going from -2 to 4. What do you see? 2 trapezoids? That's what I would see. You've got a trapezoid on the left and a trapezoid on the right to worry about. I'm going to call this T1 on the left. What about this trapezoid on the left?
1/2 times 2 times 5.
I will agree with you this time. AKA, I heard you correctly this time.
8.
You guys okay with that? Okay. And I'm going to call the other one T2.
Plus 7.
Is that a 7 up there? I never labeled, I just, put the tick marks there.
20.
Okay. So we had an 8, we have a 20, and we have 28. T1 plus T2 is 8 plus 20 is 28. The math isn't hard, is it? It's just getting all the pieces here. Man, you guys should have sat in my second hour class. Cube root of x.
No.
Just taught this graph in second hour.
It's like, I don't. Is it this? Like
Is it like
Yeah.
the
half parabola?
Okay. Half parabola is not a cube root. That is a square root.
Oh.
Because x squared is your parabola.
Wait, sideways S.
So-
Sideways S.
X squared is the parabola, and the square root of x is the inverse of it, so it's half of a sideways parabola. I think you, Aiden, drew x cubed. X cubed is the squiggle going up,
So side.
and then you put it sideways S. I don't know, or maybe it's an S. I don't know what you want to call it, but you're getting the idea. Now, I'm not going to be as specific on this one, and you'll see why here in a moment. But we're going from what? -4 to 4, yes? And the basic shape of this
it's onward.
does something like this.
Oh, they're gonna cancel out. So
Zero.
odd thing. 0.
Okay, are you guys all there? I heard odd, they're going to cancel, 0. Yeah, the idea here is when you're going from -4 to 4, we have equal pieces below the x-axis and above the x-axis. So now, why did I say I didn't need to be as specific? They're going to cancel each other out. You're going to have a positive piece up here, a negative piece up here. I don't care what the numbers are, they're the same numbers.
I like that one.
And so I have written down the integral from -4 to 4 of the cube root of x with respect to x is 0. And in case you need something to look at later, because y equals not x cubed, which is what I started to put, the cube root of x is symmetric across the origin. Okay. Are we good? That was a fun one.
Yeah.
And I don't know, maybe you guys have some shortcuts on drawing some of these, you know, like the one with the two trapezoids I just did. I just went point by point to make it. If you can kind of see it out and you can see what the final dimensions are you're going to need, that's fine. But, or I guess, if you can see it out, like on this two trapezoid one, if you could see it out, you plug in 4. 4 plus 3 is going to give you that height of 7. You plug in -2, absolute value -2 plus 3 is going to give you that height of 5. So you can find some other ways. Okay, what are you guys doing on this one? It's a line, right?
Yeah.
It's going to end up forming a
What?
what are you going to end up finding the area of again?
Oh, a trapezoid.
A trapezoid again, yes? Can I jump us over to F?
Sure. Yeah, we can do that.
I mean, E is good, but you guys see where you're going with it, yes?
Right.
It's a little more, you're going to have to go higher because it's a slope of 3. How do we do a slope of 3? Rise 3, run 1. I mean, you end up at like 14 here when you get done. Okay, that's the only tricky part there. I want to look at F because it's a little bit more, and I don't want to run out of time for it. Fair enough?
Yes.
It was 28.5 or 57 halves if you worked it out if you get to the point where you work it out all the way. If you get motivated, right? Okay, guys. The integral from 0 to 2 of 1 plus square root of 4 minus x squared dx plus the integral from 2 to 5 of 3 minus x.
It's the thing where they like equal the top and the bottom.
Yeah.
Makes sense.
So like equal
Like there's
0 to
2
2
to
and then 2
Yeah.
to 5. So
Unfortunately, no.
what?
Wait.
Okay, I see what you're saying, the 2 overlaps, but for that to work, this has to match that. Are my insides the same?
No.
No. Now, whoa, wrong button. What I can do on that first integral is I could split it into 2 integrals. And that would be a little helpful. I could say the integral from 0 to 2 of 1 dx plus the integral from 0 to 2 of the square root of 4 minus x squared dx. Plus, this is an interesting way to look at it. How did I do it in my notes? You're probably looking at this is a line, right?
Mm-hmm.
Or, because I split the last one, I'm going to show this way too. You could split this. The integral from 2 to 5 of 3 dx minus the integral from 2 to 5 of x dx. Now, I don't know that you necessarily have to split it into all 4 pieces, but the first one is very helpful. Okay. Think about the rules we've learned. The integral from 0 to 2 of 1 dx.
1 times 2 minus 2.
We don't have to draw a picture at all, right? It's the integral of a constant. The integral of a constant is the constant times upper minus lower. Yes?
Yeah.
So 1 times 2 minus 0 is going to give that piece a 2. The integral from 0 to 2 of the square root of 4 minus x squared.
That's
Fine.
the circle thing.
Wait a second.
No. Yeah. It's
We have to talk, this is part of a circle.
Yeah.
Okay, now,
It's from 0 to 2. This was
so
one high.
I see you guys flipping back. And right here, so square root of 4 minus x squared is the top half of the circle, right? On this problem, we were doing negative 2 to 2. We're being asked 0 to 2, which means we're not doing the entire top half of the circle. We're going to do that right quarter of the circle. Does that make sense? Okay. Now, the thing is, you won't always have that piece to relate to there, but it's the idea that this would be a quarter of the circle from 0 to 2. And so that is the 1/2 pi r squared. Nope, not 1/2. What did I really mean to say? 1/4. I'm like, why is this math not mathing? And so I agree. Everyone is trying to tell me pi. I agree. Okay. Now this last part, you could graph 3 minus x. Totally fine with that. Or if we split it into 3, the integral from 2 to 5 of 3.
9.
Well, okay, yeah. 3 times upper minus lower, so 3 times 5 minus 2. 3 times 3 is 9. Okay, the integral from 2 to 5 of x. At this point, I don't have a shortcut for you. I just don't, sorry. What is the graph x? That's y equals x, right? Y equals x does what? Goes through 0, 0, 1, 1, 2, 2, 3, 3, 4, 4. I have to go to 5, 5, don't I? We're specifically talking about the piece from 2 to 5, and we're back to trapezoid world, right?
Oh.
I agree. So if I do what? 4 halves plus pi plus 18 halves minus 21 halves.
1/2 pi.
If I haven't made any mistakes, 1/2 plus pi. Pi plus 1/2. That was definitely more worthy than doing the neat, just saying. Okay. And that leaves us 3 minutes to get E done.
Yeah.
As long as you guys realize when you are graphing this, you know, you're starting with a y-intercept of 2, and then rise 3, run 1. Rise 3, run 1. Rise 3, run 1. As I said, that's the tricky part. What do we have to go? 1 to 4. So I have to go 1 more. Rise 3, run 1. So let's see. 2. Okay. Woo.
Yeah.
That's a straight line, right? Ooh, that's bad. Okay. But it is what it is. 1. Ooh, gosh. Okay, I can correct that a little bit. 1 to 4. So. Mm-hmm. Where is that? Okay. Homework for tomorrow.
Yeah.
I think you'll kind of like this homework.
What?
I mean, like is a relative term. I mean, but
No.
as I look through it,
It's 24.
I feel like it very much goes with what we've done. It's properties. Yes, you've got some drawing, some pictures, finding some areas. But just glancing, I think really doable. You'll like it.